Math Blast 15, measurement conversions. If 1 meter equals 100 centimeters, then 2 4/10 meters equals how many centimeters? Well, if 1 meter is 100 centimeters, then 2 4/10 centimeters would be 2.4 groups of 100. Which is 2 4/10 times 100. Now, I know when we multiply by 100, 100 is a power of 10 number. It's like we're multiplying by 10 to the second power. And on a place value chart, to the right of my decimal, I have my tenths. And to the left of my decimal, I have ones, tens, and hundreds. And I'm going to look at this number, 2 4/10 on the place value chart. And when multiplying by 10 to the second power, my digits will shift to the left 2 times, because for each time that we're multiplying by a power of 10, the digits shift 1 place to the left. So since I'm multiplying by 2 powers of 10, my digits are going to shift not just once, but twice. The 2 becomes a hundreds digit, the 4 moves to the ones, and then the tens. And I have this ones place that has nothing in it, so we have a 0 here that needs to hold the place. So 1 meter is 100 centimeters, and 2 4/10 meters is 240 centimeters. If 1 foot equals 12 inches, then 2 5/10 feet equals blank inches. So again, if 1 foot's 12 inches, then 2 5/10 feet would be 2.5 groups of 12. And so that's 2 5/10, or 2.5 times 12. Now I'm going to multiply this out using the standard algorithm with unit form. 2 5/10 I know is 25 tenths. And I'm multiplying that by 12. So 2 times 5 is 10. 2 times 2 is 4 plus 1 is 5. But keep in mind, I'm going to put a placeholder here, and 1 times 5, I'm multiplying these as if they're whole numbers right now. 110 times 5 ones is 5 tens. 110 times 2 tens is 2 hundreds. And when I add all that back together here, I get 0, 0, and 3. But keep in mind, I have tenths. I was multiplying tenths. So I multiplied them like they were whole numbers. And then I have to look back at my units here. Tenths times ones is tenths. And 300 tenths in standard form is 30. So 1 foot is 12 inches, and 2.5 feet is 30 inches. Divide 4-digit by 2-digit. 3,540 divided by 24. Here I'm going to model the problem using the box method for division. So I'm going to start with my box that has the first number, my target number here, as 3,540. And I'm asking myself how many groups of 24, I'm dividing by 24 here. So how many groups of 24 can I pull out of 3,540 without going over? And I know 100 is a good number to start with, because 100 times 24 is 24 hundreds. So I'll subtract that from the 3,540 to see how much I have left. 1,140 becomes the new target number. Now I know 10 groups of 24 is 240. So 20 groups should be double that, 480. 20 groups of 24 is 480. I'm going to subtract that and see how much I have left. 0. 4 tens minus 8 tens, we can't quite do. We need to come over here and borrow one of our hundreds. And 100 decomposes to 10 tens, plus the 4 that's there. That's why that becomes a 14. 14 tens minus 8 tens is 6 tens. 0 hundreds minus 4 hundreds, we can't quite do yet. We need to borrow one of our thousands here. That leaves 0 thousands here. And the 1,000 I'm borrowing is going to decompose to make 10 hundreds. Plus the 0 that's there, that's why that's a 10 there. 10 hundreds minus 4 hundreds is 6 hundreds. And 0 minus nothing is 0. So my new target number is 660. All right. We have taken out 100. We've taken out 20 groups, 100 groups of 24, 20 groups of 24. I know this was 480 for 20 groups of 24. So I know I could take out another 20 groups. 20 groups of 24, again, is 480. Let's subtract it and see what we have left. 0 ones from 0 ones. 8 tens from 6 tens. We need to come over and borrow one of our hundreds. That leaves 5 hundreds, and that 100 that we borrowed decomposes to become 10 tens. Plus the 6 that's already there is why that's a 16. 16 tens minus 8 tens is 8 tens. 5 hundreds minus 4 hundreds is 100. So 180 becomes my new target number. Well, I know that 5, this is almost 25, so it's like quarters. And I know that 6 quarters would give me 150, and 8 quarters would give me $200, so 200 cents, which is too much. So let's try 7. Now let's see, if I took 7 groups of 24, that's 7 times 24, or 24 times 7. There's 28, and 7 times 2 is 14, plus 2 is 16. 168 is what we're going to get rid of here. I cannot take 8 from 0 ones. I'm going to borrow one of my tens, decompose that to 10 ones. 10 ones minus 8 ones is 2 ones, 7 tens minus 6 tens is 1 10, and 100 minus 100 is nothing. I have 12 left. I cannot get any more groups of 24 out of the 12 here, so that 12 will become my remainder. I need to add up all my partial quotients. It does not matter if you had these exact numbers as long as you're continuing to pull out here groups of 24 until you couldn't pull out any more groups of 24. When we add it all up, we should get the same quotient here. 100 plus 20 plus 20 plus 7 is 147, remainder of 12. The quotient, the answer to the division problem, 3,540 divided by 24 equals 147, remainder of 12. All right, next we have order of operations. Here, the order of operations, we are going to use our PEMDAS clue. Order of operations says I should do all my parentheses first, then exponents. Multiplication and division is done together from left to right, and addition and subtraction is done together from left to right. So as I go through the problem here, I'm going to do any parentheses first. 14 minus 7 is 7. I will drop everything else that was not underlined as it has not been accounted for yet, and we need to work with that still. We're at the exponent stage. There are no exponents here, so we are now working with multiplication and division. Any multiplication and division should be done from left to right. 28 divided by 7 is 4. Dropping everything that has not been accounted for. And continuing with my multiplication and division here, I have 4 times 5 is 20. Now I'm moving to the addition and subtraction stage, which we do these steps together. They're done from left to right. 22 minus 20 is 2, plus the 9 is 11. So 11 is the simplified expression for the expression we started with. For B, 50 times 2 minus 2 divided by the difference of 4 and 2 times 3. We're going to use the same steps, looking at parentheses first. I'm carefully going to underline the things I'm working on so that I can drop everything else that I have not used yet. There are no exponents. We're at the multiplication and division step from left to right. So 50 times 2 is 100. I have not accounted for any of the things that are not underlined. I still have some more division and multiplication. 2 divided by 2 is 1. So I have 100 minus 1 times 3. Have to finish up my multiplication and division step, working from left to right there. 1 times 3 is 3. And so I'm left with 100 minus 3, which results in 97. 97 is the simplified expression for the expression that we started with. Generate numerical patterns. Write a pattern with 5 terms, starting at 0 and using the rule, add 6. Well, if I'm going to write a pattern with 5 terms, I'm going to have 5 spaces here, which are already noted. And I'm going to start at 0, and then I'm going to add 6. So 6 plus 6 is 12, plus 6 is 18, plus 6 is 24. Now I want to write a pattern with 5 terms. Again, my 5 spaces are noted here. I'm going to start at 0 and add 2. So 2, 4, 6, and 8. How do the terms in the 2 patterns relate? Well, let's call these my x numbers and these my y numbers. If my x numbers get divided by 3, it looks like in each case, then I come out with my y numbers. So 0 divided by 3, let's see, 6 divided by 3, 12 divided by 3, 18 divided by 3, and 24 divided by 3. It would work all the way through the pattern. So I could call my rule x numbers divided by 3 equals the y numbers. The other way I could state my rule is that each of the y numbers, what's happening to get back to the x's? It looks like I multiply my y numbers times 3 to get my x numbers. So here's 2 ways I could state my rule. Using the pattern from above, complete the table below. All right, so my x numbers, pattern 1, we are calling x. We had 0, 6, and 12 were the first numbers in that pattern. The y numbers, the first 3 numbers I have in that pattern were 0, 2, and 4. So my ordered pairs will be 0, 0. The x number comes first and then the y number in an ordered pair. 6, 2, and 12, 4. Now I can graph those ordered pairs on the grid. So when I'm graphing an ordered pair, I want to go over on this x-axis here, the first number, 0, and then up the y-axis to 0. 6, 2 is my next ordered pair. I'm going to go over 6 on the x-axis and up the y-axis 2, and this is the point for 6, 2. And then lastly, I have 12, 4. I'm going to go over 12 on the x-axis, up the y-axis 4, And so 12.4 would be here. And if I connect those, then I can see the pattern there.